Not you. Read the definition that you gave a minute ago.
Again, I'm reading it right now.
Go ahead.
You're interrupting me.
I'm going
Again,
to.
I posted it. You know what? Instead of reading it, I just posted it in the chat, so you stop interrupting.
Hey, well, I'll just mute you then because you got it posted, and I'll read it since you can't be trusted. Refraction in physics, the change in direction of a wave passing from one medium to another caused by its change in speed. Passing from one medium to another. So that's not fully the law of refraction. Can you get me that? Another pertinent point.
And you could look at Snell's law as well.
It was just
Snell's law, that's what I'm trying to get you to do. Give me that.
It's just posted for you.
Yeah, no, I already described it to you.
No, Snell's law is the reference.
I also copied and pasted it.
Okay, so we got physics classroom. Can we use that citation from DJ right there? You good with that? That's Snell's law.
Let me take a look. What did DJ post?
And we've also got Snell's law from Wikipedia.
Okay, yeah. I mean, these are. Right. You wouldn't take Wikipedia though. You take Why would you take Wikipedia? You'd take a specific citation from Wikipedia, right?
Wikipedia says that air is not
Wikipedia in this instance is probably going to be.
Okay, so you said okay to that top one. Refraction is the bending of the path of light of a light wave as it passes from one material to another. The refraction occurs at the boundary. The thing you said you didn't read that.
Yeah, okay, no, I don't agree with physicsclassroom.com. I agree with Britannica.
Okay, well, you get us your citation for Snell's law that shows no interference needed.
No, I gave you the citation for refraction.
So when you're getting your refraction, you're getting your refracted and incident angles. You've got a normal line. What is it normal to?
Ask that one more time.
You got a normal line for acquiring your incident and refracted angles.
Okay.
That's for Snell's law. What is it normal to?
Well, it depends what you're measuring.
Okay.
It could be the horizon.
He doesn't even know what you said.
You got no clue what you're talking about.
To him.
Maybe I don't understand what you mean by the normal line in this case.
Yeah, because you don't know what Snell's law is, and you're trying to bullshit your way through.
Normal is 90 degrees from what?
Well, it can be... Well, it's 90 degrees from what you're measuring. That's the normal of it.
He's an idiot.
Or the subject.
Normal, a surface normal is 90 degrees from what?
The subject, in this case.
A surface. A boundary.
The subject. The horizon. Yes, the subject. That's the subject.
No. God damn it.
Horizon?
Never mind.
No.
Never mind, dude. You didn't take that math class, apparently.
Yeah, it's going to be 90 degrees to the boundary that you're going to need to apply Snell's law. Sorry about that.
Okay.
Yeah, so you will need a boundary to do that math.
Yeah, but refraction is based on densities. You could have a gradient as well.
Yeah, you need a boundary because you have a normal line. The normal
Not based on density. That's horseshit. Who told you that?
But the boundary can be a gradient. It doesn't have to be one specific line in between two media.
Who told you refraction?
Citation, please.
Density?
What do you mean citation? I cited Britannica already.
Oh, it said two medium, which air is one.
Yeah, I don't see anything about gradients in there, so give me a citation for the gradient that you're claiming.
Can I put my 2 cents in? The definition, refraction happens in different environments, not just light. So refraction of sound waves, refraction of all sorts of pressure waves.
Yeah.
What you posted doesn't apply to light.
What do you mean? Why wouldn't it?
Because light's not a wave.
Yes, it is.
No, it's not. It has wave-like behavior, but it's not a wave.
All energy is technically a wave. You can collapse the wave function into a potential point.
A wave function is the probability amplitude that you're going to make a particular measurement. It's not physically real.
Oh, are you sure about that?
I'm 100% sure.
You should take physics again.
No, I shouldn't.
Okay, explain quantum tunneling.
You idiot. You're wrong. You're going to tell him to explain quantum tunneling when actually you just told him that what it is.
He can't explain
you said it's not a particular point, but the wave function is the math that you have after you have a buildup of multiple points. You just told him it's not
it's
that.
A probability.
You just woke me up out of my sleep with that dumb shit, man.
It's a probability of what?
It's a probability of where that specific object is, that point function.
Probability
point
that you're
is
going to make
that
a detection.
But until you collapse the wave function, it acts exactly like a wave. In every possible way as a wave. In fact, it behaves so much as a wave that it can tunnel through seemingly completely impermeable pieces.
Then explain the photoelectric effect.
Oh, I used to remember this one. I don't remember. Can you remind me?
You shoot light at a metal plate and it bounces electrons off of it.
Okay. Is that that's a photovoltaic effect, isn't it?
No, it's the photoelectric effect. It's what Einstein got the Nobel Prize for.
Okay. And how's it relevant to the conversation?
Okay, because depending on you can't just like add a whole bunch of waves. Each photon needs a specific energy to knock loose an electron.
Okay, yeah. I could agree with that.
So it's not a wave.
What do you mean?
Ballistic. It's not a wave that's knocking off the electron, dude. It's ballistic.
But it behaves as a wave and as a particle, and when it impacts that other atom in space,
I've seen that Discovery Channel documentary too. You don't know what you're talking about, bro.
I haven't seen any Discovery Channel. I'm just telling you what I've learned. So when the photon hits the electron, that's fine. When the photon hits the electron, yes, it collapses the wave function and acts as a particle in that motion.
Doesn't collapse the wave function, bro. If you want to predict
purpose, that's the whole purpose of wave particle duality.
No, dude, fucking Dunning-fucking Kruger. Okay,
do you know what that is?
Yes, I'm well aware of Young's double slit experiment, dude. You're not the smartest person in the room. You're not
wave particle duality, not a specific experiment. All of wave.
Where do you think that comes from? You don't even know where it comes from.
Not the pop
wave
culture.
Particle duality came from the wave particle duality came from the Young's double slit experiment.
It was observed there, yes.
Yeah, that's where it was first observed, and that's where they constructed wave particle duality out of that observation.
It wasn't the first time it was observed, but it was the most very popular and common times.
Tell me the one before that. Tell me the one before that.
Yeah, sure. So when they put certain concentrated light through a very small slit, they would see that it would have a single slit. It would have a different effect based on that. Therefore, the amplitude. I think.
I have no idea what you're talking about, bro. You're trying to fake it.
If you don't want to listen, then I can't.
Check this out. So check this out. When we do the double slit experiments and we got a screen, right, and we look at the interference pattern, if you take like a phosphorus screen, we're only a particle.
I know how this works. I don't know why you think.
Yeah. So let me finish.
Oh boy.
Those interference patterns are composed of actual impacts of photons. It's not a wave. It makes a wave pattern. It makes a wave interference pattern, but of photons. So it makes the interference pattern of particles, the same way there's pixels on your screen, right? So the pixels on your screen make an image when combined together. So it makes the image of an interference pattern when the photons are combined together. Because we've tested this, they take a phosphorus screen to see, hey, is it smeared across photon? Is it smeared across pixels? There is no smearing. There's individual detections. In the sum of the individual detections make an interference pattern. Light's not a wave, okay? It has wave-like properties, namely the probability amplitude of making a detection. But it's not a wave.
Okay. Yeah, I don't think you understand how any of that works.
Yeah, that's not an argument, dude.
The entire point of the interference pattern is because it's like ripples of a wave on the way that it gets there. That's the whole point.
No,
you can't have individual particles act like that. How come the
actual detection at the screen is individual particles?
Because when it actually makes contact with that, it collapses the wave function. If it gets there, hold on, let me finish.
Can we read what I posted in the chat?
If there is an interference pattern, therefore it has to act like a wave. That's the whole point.
So in the chat, probability amplitude, the wave function itself doesn't directly represent a physical wave or a particle, but rather it's square.
It's square? Explain what you just said.
Read it. How about you
what
read it?
you just said. No, I want you to explain it.
I want
You
you to
have no
read it.
idea what the fuck you just said.
I want you to read it.
I'm not reading it.
Read the whole citation.
No, you got it. I believe in you.
No, what did I say? That citation says, is the probability of density of finding the particle at a particular location, which is doing a measurement. Okay? You've been either misinformed, miseducated, or just made shit up. I don't care which. Light's not a wave. Density does not determine the refractive index. You know how we figure out what the refractive index of material is? We use Maxwell's equations. And if you look at those equations, there is no matter per unit volume in them. Why not?
Yeah, but light is
Isn't density matter per unit volume? Is density matter per unit volume? Yes or no?
Is light an electromagnetic wave? Yes or no?
No.
Light is not an electromagnetic wave?
No.
Okay. I think we're done.
Anyway, so
if it is, give a citation for it is being electromagnetic.
You'll find something from high school where they told them in that.
That'll be very easy.
Yeah, something from high school. That'd be real cool. We know what they say in high school, but it's wrong, dude.
Oh, okay. So you're just gonna say all of academia is wrong?
No, high school's wrong. Upper level graduate courses are right.
Okay.
They don't teach the same thing.
Okay, so I'm going to go to science.nasa.gov, anatomy of an electromagnetic wave. Here you are. I'll read it for you. The important piece.
Do you have higher education? Or are you just coming here from base level graduate of high school?
Oh, if I was, then you should be embarrassed because I'm schooling you.
No, you're not. That's why you seem to not even understand foundational physics.
Well, this guy doesn't even know that light is an electromagnetic wave, so I don't really know where to start.
Yeah, I'm questioning you.
Okay, so you know what an electromagnetic wave is. It means that it's made up of oscillating electromagnetic fields that travel through space.
Your education. Your education is past that of high school, right?
Yes, it is. These fields, they vibrate in a wave-like pattern, and they can interact with matter, in this case electrons, for example, and they could go ahead and impact and change that matter. But it is still an electromagnetic
That's fantastic. Wave. That's Maxwell's wave theory of light, which is wrong.
Okay, you're going to tell me Maxwell
It was superseded. It was superseded by quantum mechanics, and I told you why.
Okay, explain it to me. I don't think you explained it why.
The Young's double slit, the fucking photoelectric effect, Compton scattering. Like, do you want me to go on and on and on?
But that proves that it's an electromagnetic wave and has wave-like properties.
That proves it's not. That proves it demonstrates.
It proves it's both.
Physically,
that's the whole point. It behaves both ways. That's the entire point.
No, it has a wave-like behavior. That's what I said in the beginning. But it's not.
You said it's ballistic. Wave. No, it's not. That's not how it works.
It's not. That's composed not how any of a wave. It's not composed of a wave.
Until you measure it, yes.
Tell me.
Yes, it is.
No,
that's the beautiful part. That's the scary part.
That's not scary. It's some bullshit you have to tell yourself to make it all mysterious.
Scary.
Okay, so you're actually you don't know this. That's hilarious.
You can try and posture all you want, dude. You can try and posture all you want. You have a remedial understanding of the subject. Light's not a wave. Okay. Probability amplitude of making the detection is not a wave. Okay, these are not physical waves. It's a mathematical construct.
Okay, so why does light have a frequency of a wavelength?
Just like he told you.
So why does light have a frequency and a wavelength? Why? If it's not a wave.
That's Maxwell's theory, but that gets reduced down to a photon. So it has an energy.
Yes. Once you collapse the wave function. But until then, it is very much a wave.
It's not a wave. What's waving?
Okay. Well,
dude, you can Google this on ChatGPT.
Wave function, and here I'm reading. A wave function isn't made of a particle. Fair enough. Rather, it's a mathematical description.
yeah.
Can you look in the chat? So the first quotation is from Richard Feynman, who got a Nobel Prize in Physics for quantum electrodynamics. So all these physicists agree with me. You won't find one physicist that says light is a wave. You will find remedial bullshit for ninth graders that say they shit.
Okay. So I asked you just one more time. So electromagnetic radiation, a wave. You're telling me that
Maxwell's theory.
Okay. So you don't think that's current? You don't think that's current theory? Is that correct?
No. Listen. No. What do you mean current theory? No. Quantum mechanics is the current theory.
Okay. So you don't think that electromagnetic radiation, also referred to, light, is an electromagnetic wave? You don't think that's the case?
That model is wrong. It was proven wrong by experiment. I don't know how many times I got to tell you.
Okay, it hasn't, and that's just it's what you believe.
Yeah, Young's double slit.
You should read more.
Yeah, I have read more. I've read way more than you.
The double slit experiment proved that it has particle and wave-like properties. Yes.
No, it is a particle.
Why when you first
particles hit the screen.
That's why when you first mentioned it. Yes, and of course, particles bounce off and get absorbed by our retina to give us a color, for example, right? I get that.
No,
I understand that.
The reason why I asked and they cause the screen to fluoresce.
The reason why I asked you that originally is how does quantum tunneling work? Is because
the probability amplitude overlaps the barrier, right? So you have a barrier which the particle or
is
whatever.
Is it a real particle or not? So is it a real particle or not?
There is no local theory of quantum mechanics that works. It's a non-local theory.
Yes, that's the whole point. It's a wave. It's a probability function.
It's a probability of where you're going to make a detection.
Yes, that's the whole point. And until you make that detection, what is it?
Nobody knows. It doesn't exist.
Okay.
No one knows what happens.
It doesn't exist. It doesn't exist, everybody. You heard it here first.
Tell me what exists. What is it to be?
It's a wave. It's a probability function with a frequency and an amplitude.
Of what? A wave of probability?
Electromagnetic radiation.
No, it's not.
Yes.
Then why can't we detect it? Why can't we measure the electromagnetic
article on it?
Listen, why can't we? Didn't you just say not to use Wikipedia and use the citations in Wikipedia?
Well, yeah, read the citations. I don't say read the page. At least get the citations off of it.
Yeah,
they're pretty good citations all over.
When we try to detect the wave after the slit, what happens?
Well, it depends if you actually measure it or not before.
Is it measurable?
Yes, that would mean you measured it.
No, then it would quote-unquote collapse the wave function, and then you get two frickin' slits. You get two lines.
Yeah, so it is measurable.
You don't know what you're talking about, bro. You just don't know what you're talking about.
If you do measure it, it behaves one way. If you don't, it behaves another way.
Dude, there's no measurable wave, dude. A probability amplitude is not physically real. It's a mathematical artifact.
Okay, so you know how the measurement works, right? You're bombarding it with radiation to go ahead and find out when something bounces off. That's the measurement. That's how they measure it.
Yeah, I know what a measurement is. Actually, so any interaction between quantum particles is technically a measurement.
Yeah, okay, that's the only thing you said that's true today. Fantastic. So yes, when you have those two interact, you suddenly collapse the wave function, and now how does it behave? It doesn't behave like a wave anymore, right?
Look, you're giving me the Copenhagen interpretation as if it's holy writ. Okay, is the Copenhagen interpretation
It's fairly well studied, yes.
So what? You're just giving me the interpretation, right?
Of just all of quantum physics, the yeah, that's a pretty common one.
Well, there's many bodies. There's many bodies. There's pilot waves. So there's a bunch of interpretations of what's happening.
Yes, but none of this have to do with electromagnetic radiation and it being a wave or not. All of them agree on that.
Copenhagen interpretation isn't real waves, dude. It isn't electromagnetic radiation.
Yes, but they still express themselves the same way.
Okay,
whether or not it's a field or not, or a
take an intro to
string.
quantum mechanics textbook, right? And go find light is a wave in there.
Yeah, you can find that in any textbook. Yes.
Not in any quantum mechanics textbook.
Yes, you can. This is getting tiresome.
I don't know how many citations we have to post up, dude, because we're posting
Post
people
one.
that are
Just
experts.
post the Wikipedia article.
Why, when we can go by people that have Nobel Prizes in quantum physics, why would we do that?
Yeah, and they all agree with me.
No, So
You're misunderstanding their
agree with you.
findings.
The first thing Newton believed light was corpuscular. It turned out that was very strange properties. To the point of view, it was then explained that many of these strange properties was because, in fact, it was a wave, which was wrong.
You don't have to read at me.
Which was wrong? What's ambiguous about which was wrong?
Because it's both.
So which was wrong means it was both.
Him assuming it was only a wave is incorrect.
Turned out that light was a particle. That's the next sentence.
Depends if you measure it or not. It has both properties. That's how EMR works.
Everything is really particles. All things, electrons, photons, protons, neutrons, they're all particles. There have to be no doubt about that.
This is written in the 1920s, right? And we've done a little bit of experiments since then, right?
No, that's Ramamurti Shakar, Chair, Professor of Physics, Yale, Quantum Mechanics.
Which year?
What does that matter?
Because things have been
Quantum mechanics has been unchanged since Planck, dude.
Are you retarded? Okay, I can't have this conversation with you if that's... I think we're good, man. I appreciate it. I appreciate your time. I appreciate your time.
So we have to play this game. It is particles.
I appreciate your time if that's...
Its future is determined by a wave, but the wave is purely mathematical.
No, it's not.
You can't put an instrument to measure the energy due to this wave.
Yeah,
it's
you can't measure it.
We use to determine that all will happen in the experiment.
But that's the entire point. If you don't measure it, unless there is an observer, it will act as a wave. And it's not just a mathematical wave. It is actually a wave.
It's not
the observer is the point. The observer.
That is why.
The point.
That is why you
that's
have
the literal point perspective. The observer. So you conceded the observer.
Okay, hold on, dude. In one dimension, wave functions are often denoted by the symbol phi xt. They are functions of the coordinate x and time t. But phi xt is not real, but a complex function. The Schrödinger equation does not have real but complex solutions. The wave function of a particle at a particular time contains all the information that anybody at that time can have about the particle, but the wave function itself has no physical interpretation.
Okay, so how does quantum tunneling work?
How many ways do you need to be proven wrong, dude?
Just once. Just tell me how quantum tunneling works.
I already told you.
Okay. So
the probability that makes the detection crosses the barrier. It overlaps the length of the barrier.
That's right. So the Schrödinger equation specifically tells you the nature of the matter, and the tunneling is a consequence. So the only way it can tunnel is if it is a actual wave function as a state
you're just asserting
of the
that. You're just asserting that.
Schrödinger asserted that. I'm not asserting shit.
No, Schrödinger actually railed against quantum mechanics because Schrödinger's cat was not an endorsement of quantum mechanics. It was a thing against it.
It has nothing to do with this conversation, Schrödinger's
Yes, it does.
Oh my god.
Dude, you just brought up Schrödinger as if he's affirming what you're saying, dude. He didn't. He said that this is bullshit.
Okay, do you know what a wave packet is?
A photon.
Okay, so a wave packet, I mean, it's a little more broad than that. A photon is a potential wave packet, but the entire point of that is that in a wave, tunneling is a consequence of that, the fact that it is actually physically a wave. This wave packet has a probability of that if measured.
The same wrong thing all you want, dude.
Okay, all right. Well, I guess agree to disagree. Hopefully you read a book one day.
I have. I've read all the shit I just cited.
Read a better book.
Yeah, read Wikipedia some more.
Yeah, I will read the citations off of it. You haven't.
Yeah, tell me one citation that supports what you said in Wikipedia.
I'll post one right now for you.
No, the citation of what you said.
Yeah, I'll post one right now for you.
Okay.
India, if you look at the chat, like, how do you explain more slits causing interference?
Okay,
patterns?
but if you look at the actual screen, it's a fucking particle on the screen, dumb fuck.
Here you go. Here is the Encyclopedia of Physics as of 1991. It'll show you exactly what I'm talking about, and specifically to the word actually says that. In fact, it also gives you the mathematics for tunneling in readily detectable barriers and all of the stuff if you actually care to learn about this.
Yeah. Cool. What's this got to do with what we're talking about?
Yeah, can we prove the Earth is sphere now, or are we done with physics?
This is a potential difference model of tunneling. This isn't even a wave model. What are you talking about? You think you were going to be fucking slick?
Well, no. What's the difference?
So they use something called a tunneling current because these are this is trying to model semiconductors, where they model it in an electrical engineering sense, not in a quantum mechanics or.
It works in any sense.
Okay.
The entire point of transistors is because it actually uses this, and it's talking about the fact that if we get any smaller on the transistors, they'll stop working because of quantum tunneling.
Okay. Yeah, I'm aware of that, but not.
Okay, so why argue?
It's nowhere in this what you posted. It's nowhere in that. There's nothing about quantum tunneling in this.
Yes, the Encyclopedia of Physics, 2nd edition, covers quantum tunneling.
Not the part you posted.
Yes.
Yes. Yes. What? Well, I'm looking through the words. I don't see the word tunnel in here.
Okay.
Other at the title of the page. So tunneling current, they model it the same way as you model electrical current.
So what I sent you is page 1308.
Yeah,
what
it says tunneling in the title.
Okay, so it says tunneling, right?
But the contents don't talk about quantum tunneling.
I'm happy we established that this is about quantum tunneling.
No, it's not. The title. Listen, the title doesn't control. Okay, the substance of the article is what controls.
Okay,
no.
So why do they call it tunneling?
What if they titled it frickin' Spaghetti Monster? Would that mean that the article is about Spaghetti Monster?
It wouldn't be published. It probably wouldn't be published in the Encyclopedia of Physics.
But would that mean that the content would be Spaghetti Monster?
Yes.
You're a retard. Are you?
If you title a chapter Spaghetti Monster, I would think that the chapter is about Spaghetti Monster. Yes.
Yeah, because you're a fucking moron.
Thank you. My mother tells me otherwise.
You got her fooled.
I know. I'm quite the deceiver.
So what would prove wrong the globe for you?
How do I model electron density in quantum mechanics?
Electron density?
Yeah, because there's a graphic here that says electron density and electron density. How do I model that in quantum mechanics?
I'm not familiar with that. I don't know.
Yeah, because you can't. It's not even possible.
Okay, I don't know enough about that to educate you more on it.
You don't know. You're not educating anybody.
Well, I mean, you just learned that the title of a chapter should probably reflect its contents.
Should, but it doesn't. Contents controls. Okay. This isn't quantum tunneling. Their model is an electrical circuit model.
Okay.
So we can model things a bunch of different ways, and it's a lot easier to model this with an electrical circuit model.
Yeah, that's
this is for semiconductors.
Is. Yeah, that's what a transistor is. It's a circuit.
Yeah, fantastic. Who cares? We're talking about quantum tunneling. The point is, The point is, nowhere in Maxwell's equations is density.
I didn't say it was. I don't know where you got density from.
Well, you said refraction is caused by density.
It is.
Calculate refraction using Maxwell's equations.
It can be. So the speed of the light through the substance is going to dictate the refraction.
What determines its speed?
Substances, density, usually.
Yep.
And
no, it's not density. Then where is density found in Maxwell's equation? Then where is density found in Maxwell's equations?
I don't know if he spoke to that.
I want to calculate the refractive index of the material. Is density a variable?
No, it wouldn't be.
Okay, then. What are the variables?
The refractive index is just describing at what angle would 100%, no, not 100%, but what angle would be the, I don't know specifically.
Okay,
optics.
so the refractive index, so vacuum is set to 1, whatever ratio it is compared to that, that's what the refractive index of the material is.
Okay, sure, I would agree with that.
Okay, so to calculate that, you need to know the electric permittivity and the magnetic permeability of the material. That's what determines the refractive index of the material. Nowhere in there is density.
No, refractive index is geometric. It's not a material science
It just
issue.
gets worse. It is.
Are you sure?
Yeah, 100%.
Okay, because you can scatter the light if that's what you're talking about, but the index, it should just be a geometric function.
No, it's no. Okay, so light hits the material, causes the electrons to polarize, or the atoms in the material to polarize. But when they polarize, they also create their own electromagnetic field, right? Which changes how the light propagates or electromagnetic radiation propagates to the material, right? Really simple.
Yeah, sure.
Yeah, so it's based upon the properties, the electronic properties of the material. Has nothing to do with the density.
Well, one of the properties is density. Yes, you could have more dense glass, more dense air. That's the whole point. That's why you have things like the Chernoff radiation, right? It's because the light is being slowed down because of the density of the water. Not the light, I should say, the radiation, ionizing radiation.
Okay,
Still.
It's when something's moving faster than a medium, than the speed of light in that medium. Yeah, I know what it is.
Yeah, and density is kind of part of that, right?
I've actually seen it.
It's one of the pieces. That's very cool. I'm proud of you.
Yeah, my brother worked at a nuclear. No, my brother worked at a nuclear reactor. Anyway.
Oh shit.
Well, to dismantle it. Anyway,
cool.
That's not the point. The point is that temperature is what causes refraction. A gradation in temperature. In fact, changes in temperature are 4,000 times have a 4,000 times greater effect on the refractive index of air than changes in pressure or density.
Oh,
so
okay.
Changes in temperature that matter.
They have.
And I'll give you a citation. It's called Understanding Astronomical Refraction by Andrew Thomas Young. You can go look in that.
The temperature is directly related to the density.
He didn't hear a word you said.
Sorry to jump in. No, I mean,
the hotter something is, the less dense it is.
I heard
usually, unless you have it in a container.
Listen, it's not contained in the volume, so there's the relationship between them all.
Yeah, that's what I'm saying. Like I said, it's not in a container.
Just to check real quick, you said temperature has a 4,000 times effect compared to other things.
Yes, changes in temperature.
It does.
Yes, so
I gave you the citation.
Maybe in certain circumstances it does, but the other things also have an effect, right?
Of course it does. And
I literally gave you a citation.
I know that. I'm
hold on.
He's using a 4,000 times effect in a certain circumstance.
So let's say I agree.
There's no effect.
Let's say I agree with you. Let's say I agree with you that temperature has a much larger effect than density. You have just agreed with me that density does in fact change the refractive index of light, right? You just agreed. Are we agreed that the density of the air
said the electronic property. Okay.
In fact, he did agree. He did agree.
I think he agreed, but I'd like to hear him say.
So this is another case where this fucking
you're not going to
come and interfere. No, you're going to come and interfere, so we fuck with you, and then he bails. That shit ain't gonna happen. Ain't happening this time, dude. Try again.
Okay.
So I didn't agree. What I say. Fraction is determined by the electronic properties of the material. Those electronic properties can change under pressure, or under changes in temperature, or under changes in temperature.
What does it mean? The electronic properties. That's what does that mean?
Okay, the spacing. So when a material gets polarized, right, it gets stretched. right?
No,
the,
it's
the
charged.
electron orbit, dude. The electron orbitals get
Doesn't
stretched.
get stretched.
It turns into
charges.
a dipole. It turns into a dipole, bro.
Yeah, that's what a charge is. Yes.
Yeah. So the electronic properties of the material change.
Yes. Yes, you can polarize the material.
Another thing about refraction is that it depends on the wavelength.
So yes, a polarized material can refract light differently. Yes, density, polarization, all of that matters. Yes.
The light polarizes it, dude.
Light can polarize it as it passes through and interacts. Yes. Can charge it.
Yes. Cool. That's awesome. You asked me what caused it. It's not density.
But hold on. Temperature does, but density doesn't?
Temperature it affects the motion, right? The jiggling of the molecules, right?
Uh-huh.
So you'd have to take
jiggling,
the average,
you mean the
like
energy?
Maxwell Boltzmann or something to figure out like what
energy.
temperature does. We like a lot of these things can't be modeled. We know the refractive index of air empirically. It's not known from fucking formula, right? We actually went and just tested fucking air.
Well, here's the question: is it a constant or is it based off of different parameters of the air?
Based off of different parameters. It also depends on the wavelength.
What are the parameters?
Humidity, temperature, CO2 content, pressure.
Say it. Pressure. And what is pressure?
Matter per unit, or pressure is the force exerted on the walls of a container.
Okay. All right.
That's the kinetic energy. That's the kinetic energy of the molecules.
No, that's the external force exerted by pressure. What is pressure?
The kinetic energy exerted on the walls of a container. The force exerted on the walls of a container is
the result of pressure.
No. That is pressure. That's the definition of pressure.
And pressure is based on what?
Pressure is the force exerted on the walls of a container. There is no other definition.
Okay, and what is the pressure? What causes pressure?
Temperature.
The temperature. It can affect it. Yes, but the temperature
causes pressure because temperature raises the kinetic energy of the material.
Okay, but if you have a closed volume, what does temperature do?
What is it? What do you mean? It
increases the pressure, right?
That's right.
Energy
it increases the force of the on the walls of the container. Congratulations.
Okay. And as the density increases or decreases in this case, you get what?
So if I have a closed volume and I turn up the temperature, it becomes more dense inside.
Okay, so when I open up,
how'd that happen? How'd I get more particles in there? No, how'd I get more particles in my closed container?
Well, quantum tunneling clearly, but what you can do is you can pull off
matter per unit volume. Remember, matter per unit volume. I have a volume. There's some matter in there.
What happens when you open it?
Okay, try to talk over me because you cooked yourself. I turn up the temperature. How did the density go up?
The density would go down.
The density wouldn't change. It's a closed volume.
Well, the moment that you open it, the temperature goes down. Why?
Why? Well, because it's an open. It's open now.
Okay, and what happened to it now that it is open?
Now
it became less dense, right?
They go away.
They become less dense in the container.
Yeah, the surface area. So say we have a small container and a large container, and the small container is inside the larger container. Okay. And we open the inner box. Right, and
density
and the gas molecules escape.
Mm-hmm.
What happens? Does the temperature go down?
Yes, the pressure goes down, the temperature goes down.
Why is that?
Because it's less dense.
Oh, because the surface area of the container got larger.
Well, yes, technically.
So because PSI is measured in per square inch. So I went from a 1 square inch or 1 particle per square inch hitting something to 1 particle per square meter hitting something.
Okay.
Okay, so the pressure went down.
Yes, we agree.
To do with density.
Okay, and the light or the index refractive index of light changes based on density, right? And temperature?
No.
It doesn't change on density at all?
Temperature.
Okay. If I find a citation that says that the refractive index of light changes on density, would you apologize?
Yeah, you're going to find something that says density, I'm sure, but you have to be look a bit harder. So it'll, like, if you look, say, hey, what causes refraction? Matter density or optical density? It'll be optical density. It isn't matter density. It isn't matter per unit volume. This is a fucking mistake you got. No, there's
you
optical
just described density.
No, optical density. It's not the same thing.
The fuck is that? An absorbance?
You bring up refraction and you don't even know these terms.
Well, no. What's optical density? Explain.
I'll give you a definition. I don't want to mess it up.
Is it like through one of those high like one of those blockers filters, like when you put light through a filter?
No.
Again, I'm not studied on optics, but this is pretty basic stuff.
Yeah, but you brought
optical density refers to how much material slows down light as it passes through it.
Yeah.
Yeah.
Oh, it slows down light, right?
Yeah, optical density. That's based on the polar. That's based on, if you look at Maxwell's equations, it's based upon the polarizability of the material. Told you, there's no matter per unit volume in Maxwell's equations. There's no way you can fix this, dude.
But you just said it, though. You just said it. You said
optical
that
density,
when light
not
slows
matter
down.
Per unit volume.
But you just said when light slows down, didn't you?
Yeah, optical density, yes.
So when light slows down, what is the definition of refraction?
What do you mean? What are you talking about?
The change of direction in light when it slows down.
No, we're talking about the refractive index. Refraction is when you have two separate mediums, dude, and the light transitions.
No, it can be in a gradient. It doesn't have to be specifically one angle.
Yeah, you can say that all you want, but the law of refraction states what?
The law of refraction? There's no law of refraction. Like Snell's?
There's a law of refraction, dude.
You mean Snell's law?
Fuck.
Dude, you're just fucking talking about quantum mechanics. You don't even know.
Snell's. Are you asking about Snell's law?
I'm not asking about anything.
You asked me about the law of refraction. There's no
the law of refraction. Isn't that what refraction is?
No.
Is it something else?
Just, are you okay? Which law are you talking about specifically? Snell's law?
The law of refraction is Snell's law, dude.
Okay, so Snell's law, not the law of refraction.
The law of refraction is Snell's law.
Okay, we're talking about the same thing then. Good.
Yeah. The law of refraction is Snell's law.
Okay, sure. Whatever.
Same thing.
Semantics.
It's not semantics. It's the same thing.
Literally semantics.
Whatever. Anyway, all this to fucking dodge the black swan, which I find hilarious. So, get back on something of more substance. Because
sure. How does a mirage work?
That's in dispute.
Okay.
It's in dispute in academic literature, dude.
Okay, this is.
Do you want me to post citations?
This is actually a circus.
Do you want me to post citations?
I'm actually very curious. You've got me curious. Yes, okay. Please.
I'll post citations. It's in dispute on whether it's caused by reflection or refraction.
Okay, let's say it's caused by either. It doesn't matter. The point is
not the same thing,
clearly,
right?
Yes, but what is causing this reflection and or refraction?
Well, what do you mean? What's causing it?
What's causing it? Heat differential, right? Density.
Well, you'll get like a surface layer that'll reflect. Well, because you have something called the critical angle, right? So when something instead of being refracted down, it'll be reflected off, right? So if the source is beyond the critical angle.
Agreed, but even right above that, when you don't even have to look at that specific reflective angle, you can look at the air right above it. You see it like wavering when it's super, super hot. You ever see that?
Yeah, that's turbulence, yeah.
Turbulence.
Yeah, that's what they call it, turbulence.
Okay, and what's it caused by?
Heat flow.
Heat flow?
Yeah, heat flow, convection.
Is he asking all these questions because he
why does
knows
it look
that?
like that?
Dude, I love how he's asking in a condescending fucking way, too. It's like fucking
Why does it
hilarious.
look like that, then? I'm asking you why it looks like that.
Why does it look like that?
Why does it look all wavy? Yes.
Well, there's two reasons. So the light's being deflected because of the Foucault effect. Deflected, yes, deflected.
I don't think it's
the Foucault effect. The Foucault effect in the temperature.
In the temperature.
Yeah. Why are you all questions, dude?
I don't know what that means.
So it's like deflected in the direction of
gravitational lensing? Like, what the fuck are you talking about?
If you have a medium, if you have gravitational lensing, who the fuck said that?
Oh, you said some weird.
You just Googled what I said. You just Googled what I said. That's
I've never heard it before, and Google hasn't either.
Okay, so if light is passing through a medium, and that medium's in motion, it'll be deflected into the direction of the motion.
In which situations?
All of them.
By how much?
Well, it depends on the optical path. The path length.
No, it depends on the energy.
You say how much? Like, you want that at an angle in feet, inches? Like
No, but by how much? Dependent on what? By the energy and the gravitational.
The speed of the medium. The speed of the medium. The wavelength of light.
Near relativistic.
To the optical path. No, it doesn't have to be near. This experiment was discovered with flowing water. This experiment was this effect was discovered in the 1800s with flowing water. It doesn't need to go to the speed of light.
It needs to be going relativistic speeds for it to have any kind of
no, you Googled the wrong thing, dude. You Googled the wrong thing, dude. You Googled the wrong thing, dude.
For it to actually go ahead and affect it the way you're looking at it.
You Googled the wrong thing, dude. I don't know how many times I want to tell you, dude.
Mirages are not based on this phenomenon.
You didn't ask me about mirages. You asked for shimmering road. You asked me about a shimmering road surface.
That's that's part of it. Yeah, it's a mirage.
No, it's not a mirage. You're watching what they call sensible heat flux.
Sensible heat
convection.
Flux?
Yes, dude. I'm sorry that you have a piss poor fucking education.
The term is called
fucking
mirage,
help you.
but yes, it is convection. But it's
mirage is a qualitative description.
Okay.
Hold on, dude. I'm just going to get you some experiments because you just want to jibber jabber about shit you don't know.
No, I'm asking you a really basic question. You're telling me that the density of this medium is not changing the path of the light due to the speed of the light through the medium?
It's the temperature.
The temperature is affecting the density. If something's hotter, it has more energy, it's going to try to have, or at least have more energy be able to expand. That's the whole point. When things expand, they have a lower density.
And into what?
Light will flow through them differently.
Yeah, we already covered that with the volume is increasing.
Okay, so temperature and density in a non-closed volume are directly linked. You know this, right?
In an open system?
You ever heard of a triple point, for example, based on
in an open system? When you said non-closed volume, do you mean an open system?
Yeah, when I'm not constrained.
And there is no volume, dude.
Yeah, the atmosphere.
You're not too fucking bright, are you, dude? There's no volume in an open system. That's why it's open.
It's ad hominem.
Yeah, that's really weird. So when things get hotter...
My argument wasn't that he was stupid, dude.
When air gets hotter, it gets less dense. And when air gets less dense, air or light is going to travel differently through it than if it was more dense.
You keep saying that, dude. You just keep saying it, and I already demonstrated.
It's true.
From Maxwell's equation, it's not true. You can't derive the refractive index from the density of it. You can't because you're wrong. Okay, you've been wrong a lot of times, and you just say I can't go anywhere from there. Yeah, because you're wrong. You have invincible ignorance.
Says who?
Well, no, you've conceded many things, so your arguments have always ended up in concession.
Derive the refractive index of material derive it from temperature, from not temperature, from density.
I wouldn't be able to do the math on that. Do you know how to do it?
Nobody knows how to do it because it's not a fucking variable.
So I'm reading right now, atmospheric refraction. The refraction is due to the velocity of light through the air decreasing.
Yeah, you're learning about this right now, dude.
Excuse me. I'm just reading it
all
for
he
you
has
because you
is
clearly don't
Googling
trust
questions.
me.
Can we just talk
Well,
to
no,
somebody
you don't
else?
trust
This is
me.
really
I
boring.
just tried to explain it to you. You said
Googling
that I
questions. That's
understand
all
it.
this guy has.
We're way beyond. Listen, dude. We're way beyond Googling shit.
Whoa.
We're way beyond Googling shit.
I tried to explain it to you. Then you said that what
You're
I said
not explaining anything. All you're doing is teleprompter reading fucking Google. Google's wrong.
You asked for citations earlier. You don't care about citations anymore?
Citation, a peer-reviewed citation, post in the chat.
Okay, yeah, let's do it.
With experiment.
Sure. This may be the most bizarre thing I've done in a while.
Yeah, sure.
Will you be able to involve the entailment and the reference into the experiment? Or are you just gonna post a link and then do the citation? Just sort of you make the argument. This is your argument now.
Yeah, I did.
You don't need some researcher anymore because you're interpreting the data.
Understand.
Yeah, well, no, I'm just reading what the researcher concluded. I'm not a scientist.
I don't care about his conclusion. Don't care.
Okay, so you don't
only care
believe
about
in
data. I only care about data, dude. I only care about data.
How do you think you get the data? How do you think you can get the data then? Other than measurements.
If it's peer reviewed, that means he did some sort of experiment, right?
Yeah. Yes.
Yeah, so the data.
But what about it?
I'll interpret it.
I want the data from your citation.
You want the raw data so you can interpret it?
Yes.
Are you a scientist?
Did I stutter?
God damn it, dude. Are you serious?
I'm asking you a serious question.
Seriously?
Yes, I am a scientist.
Okay, I don't believe you, and I don't think
I don't care.
You don't have to believe it.
Because that would be a genetic fallacy anyway.
This is already going nowhere. It's been going nowhere for the last 45 minutes.
I'm not sending you raw data from somebody's fucking experiment.
Okay, so you asked so I said, what caused Mirage is in dispute. I just posted in the chat, dude.
Yeah.
2 papers with experiments. So they do experiments to demonstrate this shit.
Okay. Fantastic. I'm not going to read those because I don't own those books. Do you own these books?
They're not books. They're in journals.
These are books, yes?
Yes, the library goes to, yes, I have part ownership to the public library.
What books? These are journal. These are journal articles.
Okay, can you take a screenshot of them so I can read them?
No.
Okay, because you don't have them and you haven't read them.
Yes, I have read them. You can go on Google Scholar and look these up and read them yourself.
Okay, so link it to me.
No.
And this is just reversing the burden.
Clearly, you can't prove it.
You're here to prove it. I told you where to go and how to find it, right?
You can't
Take
prove
the
it,
first title, go to scholar.google.com, type it in, copy paste this in, and it'll bring you to the paper. Read the fucking paper.
Okay, so you can't prove it.
Yeah, I just did. What I proved is you're lazy, and you actually just trolling, and you don't even really care about this shit.
If you say so. I could say the same about you.
Yeah, I know you are, but one of mine, because I'm 10 years old, and all I got is know you.
Yeah, I mean, that's the extent of you. It's just ad hom with you.
Yeah, he just did it. He did it again. That's crazy, dude.
Okay, here are all...
here we go. You're going to do it again for the 3rd time? You're going to say no you for the 3rd time? Please do.
Oh, no, I'm giving you all the citations you want.
Yeah, Wikipedia is not a citation, dude.
I'm not giving you a Wikipedia citation.
You mean not again?
Oh, sorry, the citation's way too long. I have to cut it down into multiple pieces.
What the title?
Perfect. Here are all the titles. You can read them. Enjoy. I'll wait.
Okay, let's just take a random one. I've read the Andrew Thomas one. I read the Fletcher one. I've read not the Shackleton one. Shackleton one has nothing to fucking do with any of that crap.
What do they say?
So astronomical refraction at low altitudes of marine navigation is he's going over very strange observations that people have made, such as floating icebergs, the Barents fucking expedition that got stuck in the Arctic where the sun rose 2 weeks too early.
Okay.
So that's one. Shackleton, I don't know what that has to do with the fucking price of tea in China. I think you just Googled any fucking thing. Astronomical algorithms. I think that's probably the refraction correction for astronomy. Mathematical astronomy. Do you know what it says in any of these?
No idea.
So, and I'll also tell you, these are astronomical refraction. Astronomical refraction is not terrestrial refraction.
Refraction near the horizon from the Astronomical Society of the Pacific.
Astronomical refraction is not terrestrial refraction.
Refraction near the horizon.
Are you listening to me? You posted a bunch of citations for astronomical refraction. We're talking about terrestrial refraction.
Okay.
Yeah, it's not the same thing. They don't use the same model. They don't use anything the same. Terrestrial versus astronomical.
Okay, what's the difference?
Between the land and the sky? Are you fucking high, bro?
That would be light entering the atmosphere from beyond the atmosphere, while terrestrial deals with the refraction that you claim is occurring within the atmosphere, light generated from within the atmosphere or reflected off surfaces.
That's right. So if the light is coming from, for example, the sun, which is over the horizon, we would talk about astronomical refraction. And if we're talking about terrestrial refraction, we'd be talking about reflections of what?
Apparent displacement of objects outside of the atmosphere.
Okay. Where is the light coming from?
Yeah.
On the land?
Where's the light?
On the water?
No, where's the light's coming from the water?
No, that was a question. We were talking about the black swan. But we were talking about the black swan.
The sun. It's all coming from the sun.
Yeah, that's the original light source, but do you think it like the sunlight memorizes the refraction when it reflects off the oil rig and affects how you see it? What a fucking disingenuous cock,
still coming from there.
So what?
It's still coming from there. It's not just one thing or the other. Refraction works either way.
Yeah, it has nothing to do with the source of the light, dude.
But hold on, atmospheric refraction has nothing to do with the source of the light. Atmospheric refraction has nothing to do.
We're done wasting our time, like with
terrestrial.
So check this out.
Are we done?
No. I'm going to show you something because you're just about to get cooked, dude. So I should have just went right to this.
I've been cooking you for an hour.
Now look in the chat. Now look in the chat.
You're well done already.
Now look in the chat, dude. Now look in the chat. Is this refraction too?
Look at the chat.
Is this refraction too?
Yes.
Okay. So look at the bottom of the oil rigs. You see the rig lights? The source of light isn't the sun. The source of light is a light that's on the oil rig.
Sure.
You see it reflecting? You see it reflecting off the water?
Yeah, refraction works no matter if it's terrestrial
so you can reflect. No, reflection has to, because there's a law of reflection. The angle of incidence equals the angle of reflection.
Yes, and it has nothing to do with terrestrial or astronomical.
No, dude, it has to reflect off a real surface. It can't reflect off a mirage.
But it has nothing to do with terrestrial or astronomical. Refraction.
Are you not understanding what I'm saying? Are you not understanding what I'm saying?
Yes.
This horizon.
So dense air is bending the air. Bending the light.
You don't even know idea. Okay, the light that's reflecting off the water at the bottom of the oil rig is supposed to be reflecting off of water that is curved away from you. Because the horizon here is only supposed to be 4 miles away, but these rigs are 9 and 10 miles away.
Okay. And
so the water surface
is bending that air. Bending that light, excuse me.
And that's what the light is reflecting off of?
It's not reflecting, it's refracting.
It's reflecting off of water.
Okay. And so before it touches the water, what's it doing? It's refracting through dense air.
Yeah, but it's reflecting off of water, and we're seeing the reflected light. We see the light and the reflected light. But the reflected light has to bounce off a real surface. It can't bounce off an imaginary surface.
Yes, I understand the reflection is being done on the water, but the refraction is being done through the air.
Yeah. What do you mean the refraction is being done? What does that mean?
The reflection is off the water. The refraction is through the air. Through the entire time it's moving through.
Be more specific, dude.
I can't be more specific.
Of course you can't, because you're just saying gibberish.
It's impossible to be more specific than what I just said.
No, it is not.
I think I've been very specific.
That water that the light's reflecting off of, the reflected light that we see, is the refracted image of a light.
Give me 1 second, please.
Why can't you just answer that? Is that the reflection is from refracted light that
hello?
Around the corner.
Yeah, so let me give you why that don't work.
What?
Because that surface the light is reflecting off of is supposed to be tilted away from the camera.
Tilted away.
Because it's on the it's supposed to be physically on the other side of the curve.
Yeah. Oh, that makes sense.
That water should be on the other side of the hill, dude.
Oh, but it is. That's the great part.
Oh, it is. It is.
Yes, and I'll actually show you a diagram.
Okay, it is. So tell me how that works. When the angle of incidence listen. Tell me how that works when the angle of incidence equals the angle of reflection, because it can't reflect to the camera.
Again, I'll show you a diagram for it. I'll do you.
Oh, please do.
I don't think I'm able to post images here.
Oh, do MS Paint, man, so we can save this shit.
No, I don't think I can. I can post images because I keep leaving the server. Let me share a link to it, maybe. Let's try that.
You made this diagram just now?
No, I just copied it to illustrate because you said I wanted me to be more specific. So here's a good one.
Yeah, specific about this observation.
Yeah, so this is I think this is pretty specific for your observation.
Yeah, that's not how it works, dude. We're talking about the reflection. So I'm going to take your little diagram. So here's the funny part. I'm going to take your little diagram.
Mm-hmm.
Now remember, angle of incidence equals the angle of reflection.
Mm-hmm.
Supposed to be dealing with the reflection, bro.
What about it? If you put that...
what about it?
What I'm saying is, what exactly do you feel is wrong? If you put that rig further along the horizon, this same result, you're going to get the same result.
Where in that diagram shows the reflection of the lights on the water?
Well, you could just draw a line.
Oh, I'm gonna.
Yeah, that's what you were asked to do.
I think you can kind of visualize it, right? You have a internal monologue and you're able to visualize things in your brain. Are you MS painting it right now? Because that's hilarious.
No, I'm just drawing on it. I'm drawing arrows to the reflection path.
Perfect. I'm happy you do the work. Most people here are usually just the circus animals. They don't quite know how these things work. I think at least you put the effort in. I appreciate that.
Circus animals. How ironic. So check this out. There's no possible reflection path, dude.
Yeah, so there is.
It's on the other side of the hump.
Yeah, so just like the curved path of the light going from across the horizon, you would find a single angle from that point to your eye that does in fact complete the reflection path. So in this case, in your image, it would have to be much more shallow, the reflection path. One of the reflection paths is going to hit your eye.
Yeah, but you see it in a location, right, away from the oil rig. Mm-hmm. So you know where it's bouncing off of. You know the angle.
Yeah, absolutely, and it curves just like any other light.
No, dude, It can only reflect at the angle it strikes the water. We can figure out the angle it struck the water. How?
Mm-hmm. How? By measuring the angle between us, the water, and the
the light. So there's a light on the rig. There's a light. The reflection of the lights in the water. You can guesstimate the angle that it hit the water.
That'd be very difficult because of refraction.
No.
Yes.
No.
Yes.
No, it wouldn't, because then you'd just be seeing a virtual image of it, right?
It would. It's not a virtual image. It's a refracted image of what you see.
Yeah, a virtual image. It's not real,
it's not
right?
A virtual image.
Is it the actual object, dude?
Is it the yes? It's the actual object. Just the light hitting your eye has been bent.
Bent.
If it's the actual object, then you should be able to shoot it.
Well, I think that's a really maybe with a laser, yeah, but it's probably not going to be there if it's a laser. Actually, if it's a laser, it would get refracted too, depending on the strength of the laser. So yeah, actually, it would be fine.
Would a bullet get refracted?
We have to go this far.
Well, bullets are ballistic. If there was no gravity, then you'd miss it too.
It is. So what you're saying isn't the thing that you're saying you're seeing. It's not the thing.
If the bullets were affected by refraction, yes. Bullets are not affected by refraction. Hello?
Yeah, hold on, dude. I got to make another MS Paint to fucking show you're a moron.
Oh, I can't wait. This is fun. Are we still on YouTube, or is this more of a private conversation now?
Yeah, it's still on YouTube, dude.
Oh, fantastic!
Hey,
hopefully, we've educated some people. Hi, YouTube.
So I can show you how real of a nigga I am.
Oh man, I bet you're a big nigga.
So
you might nigga.
Still, no path, dude. There's no path. It's not possible.
Your problem is the straight lines. Your problem is the straight lines.
No, the problem is you're behind the mirror, dude. Behind it.
No, but if you were to bend
you're behind the mirror. Okay.
Behind the mirror.
I'm challenge you. Here's the challenge. Take a mirror so that you're behind it. So the mirror is tilted and you're behind the surface of the mirror.
Mm-hmm.
You can create any refractive condition you want. Use CO2, use butane, use fucking water, use whatever. I want you to show us that you can see something reflected off the surface of that mirror. It's ridiculous, and you know it, dude.
Reflected, something reflect. Yeah, I just look at the mirror. Everything's reflected off the mirror.
Not if you're behind it.
If I'm behind, like I'm underneath.
Yeah, you're behind it. You're behind the mirror. You're on the other side of the curve, right?
I understand what you're saying now. Okay, all right. So take that same diagram, but move.
Yeah, okay. Deflect from the mirror experiment. Yeah, deflect from it, dude. No, you can't. Yeah, we're not doing thought experiments.
I'm answering your question. No. I'm answering your question. So let's move that oil rig as part of the model here. Let's move that oil rig far over to the right side. Far over. You see that orange line? Let's see. It's far over, already over the horizon. Not before the horizon, over the horizon. If you go to the refraction, the top one, imagine that, however, with a high refraction index, which is the bottom. So combine the ideas. You see the top one that says low refraction in the horizon? That's the model we're talking about, where the bottom part is obscured. We would have the light bounce before the horizon and then still hit your eye. However, if you have a high refraction with the bent lines that we're talking about at the bottom one, you can quickly see how those bent lines would still be able to hit your eye.
Yeah, that's a cool story, but you can't demonstrate that in any experiment.
Yeah, in the video you posted, it's actually a demonstration of exactly what I just described.
No, it's not. Like I said,
you've done the work for me already.
If you took a mirror and you were behind the mirror surface, right? So at an angle, a negative angle, right? Mm-hmm. Parallel is 0. You're at a negative angle to the surface of the fucking mirror. You're claiming that refraction can let you see the surface of the mirror.
Yes.
And the light reflected off of.
Yes. Absolutely. That is how refraction works.
And why do you think that?
Because that is a demonstrably known and like this. How does light work?
Demonstrate it.
This is well known.
Demonstrate it. Demonstrate it then.
Sure. Let's do it.
Silly dude.
Okay, so you're not actually interested in the evidence. You're already...
No, it's you don't have any evidence, dude. You have a bunch of ideas in your head.
In fact, refraction can work so well that you could actually see the back of your head if you go around the world.
Now you're just trolling, bro.
Yeah. Okay.
Here. Does that make the globe? Does that make the globe unfalsifiable?
Oh, if it was a religion, maybe. But I'm giving.
No. That would mean that there's no observation we could do that couldn't be explained away by refraction, right?
There's plenty. There's absolutely plenty.
So, like what?
Well, I mean,
while you're talking, make sure you're still looking for that evidence because I don't have goldfish memory, so I didn't forget.
I can't do both, so you'll have to wait then.
Okay, I'll be waiting until hell freezes over.
You give me not enough credit.
Yeah, you're googling shit on the fly, dude.
Well,
we've debated Google before.
Do you want me to just draw one up and do an experiment?
Google's intelligence is not your intelligence.
It's not Google's intelligence. I use Google to find other people's papers. I don't use Google as a
the papers you didn't read?
Well, no, I didn't read them all, no.
You didn't read any of them?
Yeah, you haven't...
You didn't even post the right refraction. You posted astronomical refraction.
In this case, any refraction is...
No, it's different. Refraction. It's different.
I posted atmospheric refraction.
Different.
How is it different than atmospheric
Astronomical refraction is not quote-unquote atmospheric refraction. Called terrestrial refraction. It's different.
What's the difference? No, atmospheric refraction and terrestrial refraction are two different things.
The model used is the difference.
What's the difference?
I'm going to say it again for like the
Describe it.
Because I said it earlier too.
Describe the difference in the model.
Because one uses variables such as pressure, temperature, relative humidity, CO2 content, where the other one just uses an air mass model.
So what? It's still using refraction. It's still the same law.
You're not using the law of refraction because you said Snell's law is not applicable.
Are you getting...
And you already admitted Snell's law is the law of refraction. Now you're fucking contradicting yourself again.
Are you getting anxious that you're laughing anxious?
No, dude. You're trying to posture now. It's fucking transparent.
Oh, simple question.
No, you're just trying to... It's just transparent. Now you're trying to turn me into the subject matter. Because
you're the guy who said that light is not an electromagnetic wave.
It's not.
I mean, that was an interesting one.
Yeah, it's not.
Can you say it just one more time? I need that.
Yeah, light is not an electromagnetic wave. The Maxwell model is wrong.
This is the kind of person we're talking to, folks.
Yeah, the idea that you're going to socially shame me, right? And be like, he don't believe that light's an electromagnetic wave. That's all we all learned in 6th grade. I don't give a fuck what you 6th graders think.
But you already know that. I don't need to shame you. You've already shamed yourself. I can't shame you more than you could shame yourself.
Yeah, okay, more posturing.
It's true.
Yeah, see, this is what you guys all do. We flat earthers become the topic when you get cooked on the actual topic.
Well, I mean, it was all ad hom from you earlier.
Did you find the experiment yet? It wasn't an ad hom.
Take it yourself, can you?
And you don't know what an ad hom is, obviously.
People in the chat were making fun of you because you're using ad homs.
Yeah, it's not an ad hom. I don't care what people in the chat think either. So
I know reality is whatever you believe. Right?
Yeah, no, because these things have definitions. So ad hom is when you try to prove a proposition.
Using them. That's the problem.
Ad hom is when you try to prove ad hom is when you try to prove a proposition by attacking the other person's character, some personal flaw that you have. I didn't try to prove a proposition that way. I actually proved the proposition.
Yeah, you said because I'm uneducated.
You for not knowing.
It's an ad hom.
No, an insult is different than an ad hom.
It depends on the insult.
I wasn't using your retardation as proof of a proposition. I was just highlighting your retardation as an insult.
Well, as a disproving of my proposition.
You don't know what an ad hom is. Oh, believe me, you did.
I really didn't.
I really didn't. No, you. You're going to do that again? No, you.
It's fine. Yeah, quite the cute
do you
voice
got
when
that
you get
evidence
anxious.
yet? Do you got that evidence yet?
No, I don't think
Yeah, I'm
any
anxious for the
evidence.
evidence. Please,
I
hurry
don't
up.
think any evidence is going to change your mind.
Oh, the cope. But no evidence will change your mind. Cope.
It's been 2 hours, and you still don't think that electromagnetic waves is, light. It's strange. It's strange to me. You're a strange person.
And it's going to be forever.
You're a very strange person.
I'm beyond high school physics. Because I'm beyond high school physics.
Yeah, you're beyond reason, apparently.
He's going to go back. He's not going to give you the evidence that he was going to give. Is that what's happening?
At this point, it's just dunking on the losers.
Yeah,
so you're not
fake it till you make it. Remember when we had to post the freaking you said you didn't say something, and then we posted in a chat. Remember how you came in here and said you were a pilot? Remember how you came in here and said you saw curvature, denied it, and then someone had to post the clip? Remember, do you have goldfish memory? Do you remember all the bullshit you tried to peddle? We do.
Number one, I fly. Number two, I still agree with the clip.
No, you said you're a pilot.
Yes, I fly planes.
Yeah, stop the cap, dude. You didn't.
Okay, man.
Were you student pilot or something? You sit next to the guy?
Yes.
So what? Then I fly a plane because I sit next to the pilot. What you fucking do?
Well, no, I'm learning to fly. Yes.
Well, I think what you should learn next is learn how to parachute.
I mean, you should learn how to read, honestly.
Yeah, nice cope, dude.
I mean, I would cope if I didn't know how to read. That's really upsetting.
Look, see, here's the funny thing is, everything I talk to you about, I didn't have to Google any of it. I already know all that shit. But you were Googling it.
It's tragic.
Yeah, it is tragic.
That's the worst part.
I don't need Google to tell me what to think. I go by the academic literature.
Yeah, I posted Britannica. I posted everything. And what did you
Britannica, post? And you use the definition for actual physical waves.
Yes, because that's how
light's physical waves now.
Yes. It acts like a wave.
Stupid, dude. It's not physical waves. I don't know how many.
I'm not
how many Nobel laureates do I have to post telling you you're wrong?
A 1 would be fine. Actually,
I did. Richard Feynman.
Richard Feynman agrees with me. And when I asked you, when your white paper or whenever your article was,
you just said Richard Feynman agrees with you. I'm going to read it again.
I said, what year was your journal posted? And you didn't want to answer it because it was in the 1800s. And I said, yes, we've had different experiments.
What are you talking about?
Then. Oh, you forgot already. Thankfully, it's on YouTube and we can clip it.
Young's double slit?
No.
You mean Young's double slit?
That. No, not the double slit experiment. That was done way later.
It was done in the 1800s.
Okay. Saying way later than the one that you were talking about.
Which one? Be specific.
I don't remember now.
Einstein's? The photoelectric
effect?
That
was later.
The Compton effect?
That was much later. You know that.
The earliest one I talked about was Young's double slit.
Okay, great.
And what does that have to do with it? Does the physical world change with time?
The way we understand it does, yeah.
The way we understand it. What does that even fucking mean?
That's what science... the way we understand it changes? You don't understand what that means?
That's a statement about humanity.
That's a statement about knowledge.
No, it's a statement about what human beings think, dude.
Yes, I agree.
Understanding is what a human being does. The physical world don't change.
Well, some of us more than others, especially in this conversation.
Yeah, exactly. You know, the fake it till you make it shtick. Imagine that working. It's never going to work, dude. None of y'all's gimmicks ever work in here. So maybe you should take it to one of your fucking atheist chats or whatever the other stupid chats.
Atheist chat?
Yeah, when you're fake it till you make it, when you get cooked and you just pretend you didn't get cooked, and then you pretend the other person got cooked, even though everybody heard you get fucking throttled.
But you think electromagnetic radiation is not a wave?
The words no.
Think.
So
and then when I show you refraction,
I graduated 9th grade, dude.
When I show you refraction, you say, "Oh, is atmospheric or terrestrial?" Like that even fucking matters.
Wrong. It's astronomical or terrestrial.
Sure, whatever. It doesn't matter.
Sure, whatever. Words don't mean things. Remember, you're cooking me. Just remember you're cooking me, dude. Just remember you're cooking me, dude. Just remember that. You're
absolutely.
But you can't even remember the conversation fucking 10 minutes ago.
Except you're delicious, obviously, right? This delicious cope is what I have.
This is going nowhere.
Oh, absolutely. I mean, hopefully it's going to educating you about something, but I don't think we're ever gonna
more fake it till you make it boring.
There it is.
You got a new shtick. Boring. Fake it till you make it.
Got anything fun to talk about?
Remember you came in and said you win right off the bat before you said anything.
Yeah, I'm still winning.
Yeah, and then you started lying, dude. Right? You said, and also you said you fly planes at 30,000 feet, right?
Yeah, I've sat in the cockpit.
Yeah, what kind of plane? At 30,000 feet, what kind of plane were you in, right? Because in training, right, they usually fly between 3 and 10,000 feet, right? Not 30,000 feet. What were you in, a Boeing 737 or something?
I literally just said that, yes.
You didn't get trained at a commercial fucking airliner, you lying savage.
No, but I was sitting in the cockpit and I was able to touch the controls. This was the 80s.
Yeah, I bet you were touching the controls. I bet you were.
Yeah, and he showed me how everything works.
I bet. You in the Mile High Club now?
I wish. That'd be interesting. I should probably ask my wife.
Yeah, I bet. Does your neck still hurt?
I mean, kind of weird gay joke. It says more about you.
I'd like to quickly ask him a question that's related to the Earth. Hey, buddy, what would prove wrong the globe for you? What can you do or what can you see that would disprove your belief in the globe, like make you no longer believe in the globe?
Oh, it'd be really easy. It'd be super easy, actually. I mean, if you saw all of these different experiments on curvature and everything like that, if you gave me equal evidence, not even better evidence, equal evidence to this stuff, I would probably start questioning my position, but I just don't see it.
Like which one?
That's vague, dude.
I mean, I'd love to see some experiments from your
Which
end.
one? Which one, dude? What's the best one?
Any of them. So, okay, I'll just list a few.
Yeah,
sure, I'll list a few. So the first one I started with is the Greeks. You know that one, obviously. Like you said, you know this better than I do. Next one would probably be the further you are away from the Earth, you could do it geometrically. The further you are away, the more of you can see. You can also do things like look at the horizon and see how it refracts over the horizon, or at least find out if there is no refraction or less refraction. You can calculate it very well, like you said, over that gray swan piece. And another good one is looking at what the Earth potentially looks like as a obfuscation of lights on the moon, for example.
What a bunch of fucking horseshit. This dude, you're shoveling.
A bunch of horseshit.
Just horseshit, dude. You're just shoveling horseshit. Oh, I went higher. First of all, dude, so check this out. So how did toddlers, right, when you're a toddler and you can't walk yet, why? How come you learn how to walk? What motivates the toddler?
Because you have a strong
because you can't see as far. Because you can't see as far.
No. See, some of us have a strong present father. You didn't, so you wouldn't know that.
Yeah, you're the one who actually said my mom, okay? So, seriously, you
Who
literally...
said your mom?
You did. No, you were talking about your own mom and how your own mom is proud of you. No fucking man that had a father would ever say that shit.
Really? Your mother was never proud of you?
You're raised by a single mother, bro. You gave it away.
Well, the difference is that my father would never say that to me. My mother would because she's soft. My father was not.
So now that you're done trying to change the subject, so why does a toddler learn how to stand up so he can see the rest of his toys?
Lady boy.
So he can see the rest of his toys, right? It doesn't mean his house is a globe, right? Doesn't mean his house is a globe, bro.
If you take a tennis ball and put it right in your face, and then you take that same tennis ball and move it away from you, you're going to be able to see more of the tennis ball. Try it.
Yeah, cool. But if you stand up, you can see farther. That's why we climb a tree. We don't climb a tree because the Earth's a globe, bro.
What do you mean? You can go ahead and you can stay on the ground and see how far you can see. Go to the 10th floor, see how far you can see. Go to the 100th floor and see how far you can see.
Yeah, you can see farther. That's not a mystery, dude. It's the same everywhere. You could be on a pretzel, the back of a fucking dinosaur, on a fucking gigantic shark. It doesn't matter. The higher you go, the farther you'll see. It doesn't.
Here's the beautiful
part.
Listen up. You could go to the ocean at 1 foot.
You can measure what it would
look
like.
Still talking the whole time. That's fucked up, bro. You were muted. You were talking the whole time. You're such a tard.
Well, I was waiting for you. The guy stopped talking, so I responded. So, yeah, I mean, it's really simple. You could just measure.
Is that exclusive to a globe? Yes or no?
Hello?
Is that exclusive to a globe?
If you listen, I'll be able to explain it to you.
You could just. I don't need your explanation. You're just trying to kill time. Is it exclusive to a globe?
Do we have a limited amount of time?
Is it exclusive to a globe? No, you're time wasting. Is it exclusive to a globe? Yes or no? Going higher,
Depending on the
farther.
measurement.
Is it exclusive to a globe?
Depending how far you can see, you could geometrically determine how far you should be able to see. Yeah, sure. So on a flat plane, you'd be able to see further. On a globe, you'll be able to see less,
much further?
depending on how high you are. Depends how high you are.
100 feet. What's the difference?
I don't know. It depends on the size of the globe.
So you're just making shit up. So you're making predictions based on nothing.
No, it depends on the size of the globe in this case. You can do it geometrically.
Well, according to you, it doesn't depend on the size of the globe because you made the globe unfalsifiable, and you should be able to see 25,000 miles your own ass, remember?
Well, no. If it was a flat plane, you'd be able to see further.
You said you should be able to see your own ass with refraction, right?
Oh, well,
so you'd be able to see 25,000 miles on a globe. So even if it was a 25,000 mile, even if it was a 25,000 mile flat plane, that would not falsify the globe to you.
Technically, yes, you can refract light into a circle.
One sec, bro. You just said if it's flat, we should be able to see further. Black Swan, bitch.
Yeah, we do, bro.
Yes, that's refraction, which will allow you to see.
See how it's unfalsifiable now? It doesn't matter, does it? Whatever we observe, you're going to say, because globe.
No, because
you know what that's called? Do you know what that's called?
Hold on.
You know what that's called, though? You know what the definition of pseudoscience is?
It's called a religion, yeah. Okay,
no, it's called pseudoscience. It's the very definition of pseudoscience. So
I don't feel the need to have to defend it. I'm just telling you what my observations are.
You didn't make any observations. You're just talking out your ass.
You haven't given me any kind of counter-argument.
We don't need to. You're making baseless assertions.
Okay, then what are your assertions based on?
We see it because it's there.
Me too.
So it's very simple.
Great argument. Great argument so far. Well done.
Yeah. I mean, we see it because it's there. Because
starts with the conclusion.
We see it 10 mile away horizon because it's not a globe of 3,959 miles. Really simple, dude.
Yeah, and what I see, based on my observations, is a globe the way we understand it. The way science understands it, really.
Where did you see that? What science understands it? Now you're
from all the different things that I can see. Well, I mean, science is the practice. Science is the method. Yeah.
No, science is a Jesus Christ, this is
science is a method.
Yeah, what is the scientific method?
It's a method.
Yeah, what is it?
You just want me to recite it from the top of my head?
No, I don't want you to I know you need more time to Google it, so I'll tell you. First step of the scientific method is observe a natural phenomenon.
Why are you doing this? This is cringe.
So what is a natural phenomenon that you're observing, dude?
Doesn't have to be a natural phenomenon.
Yes, it does.
No, it doesn't. Could be a man-made one.
So you'll know the cause and effect relationship? Yeah. Of a man-made thing? Yeah, we know what the cause is.
You just need to observe something.
So man is the study of nature. Man-made object is observing a man-made object is a study of nature.
You said a natural phenomenon.
Yeah, science is a study of the natural world and the things in it.
Okay.
Man-made is synthetic.
Why would you science something that you know how it works to begin with?
To make sure you still understand how it works? Or using, that the whole point is the experiment part. Have you heard?
Is that like how they did Apollo? We lost the technology. It's a painful process to build it back, so they had to study it again.
Okay, so I want to know how a brake shoe works. Next year, is that going to be different?
You can go ahead and study the stars and figure out that you are the center of everything.
That's not man.
You study them again, and because you realize that there's the retrograde, you go ahead and pick a different model, and you go ahead and go with a different way. So they studied the same thing, but they found a different conclusion because they have a better understanding.
No.
That's why you run experiments. They have better experiments.
Wrong. It's philosophical, so it's the Copernican principle. They didn't observe that we weren't in the center. You can put the center of the coordinate system anywhere, and now they have something called the cosmological axis of evil. When they observe the so-called cosmic microwave background radiation, it looks like we're in the center.
Evil! Did you say the axis of evil?
Yeah, the cosmological axis of evil is what science calls it.
I've never heard this before. What is this?
You haven't heard a lot of shit before. We know. It's because the cosmic microwave background radiation makes it look like we're in the center of everything.
From our perspective, I guess. You know how that works, right? Because light's moving away from us in all directions, so it seems like we're the center, but we're not.
No, this isn't moving back and forth. This is a residual radiation.
Yeah, but it's moving away from us.
No, it's not.
Yeah, so that radiation is from the beginning of the universe.
Yeah. It's everywhere.
And it's coming.
It is the universe.
From where?
It's not. We're in it. It looks like it's coming from us.
It's coming from us?
Yes.
No.
Do you know what I find funny? You've never heard of it, and you're trying to argue it. You're a mental case.
I understand cosmology. I've just never heard this axis of evil.
You don't understand shit.
Paradigm.
What is the CDM and Lambda CDM model stand for? You study cosmology, this is the easy one. This is a fucking softball.
What, just the model in general?
Yeah, what is the CDM and the Lambda cosmology? Yeah, do you need more time to Google it?
What do you mean?
What do you mean? I didn't Google it fast enough. Fuck, dude, it doesn't come out.
It's literally just dark matter. It's the standard model.
Yeah, that's what you just read, man. You're almost intelligent.
Okay, ask me a question.
Make it till you make it. You're a clown, bro.
Indio, this is the AI bot that you don't pay a subscription for.
No shit.
Okay, so are we proving a point here? I answered your question.
Yeah, that you don't fucking know anything, and that we're just really debating fucking your ability to fucking Google shit.
I mean, shouldn't you be able to research this too?
I don't. It's already researched. I don't need to Google it, dude.
But clearly, there's some discrepancy between what
there is no discrepancy. You don't know what you're fucking talking about.
Maybe
you don't know what you're talking about, and just trying to use genetic fallacies. Oh, they're wrong because they're flat earthers. Sorry, dude, that don't work. That's a genetic fallacy. Doesn't matter what the source of the information is. Doesn't matter what the source of the information is. You don't know anything about the fucking topic, and you're just blabbing. You don't know anything.
The literature says different than what you say.
Yeah, what's it say that's different than what I just said?
And then you asked me to cite something, and then when I cite it,
what does it say that's different than what I just said?
Me to research it.
What does it say that was different than what I just said?
Well, that the electromagnetic radiation is not a wave. That's something that's different.
What literature? Ninth grade textbooks. Ninth grade textbooks.
Anything past
in any quantum mechanics physics book, and it didn't say it in the citation you posted, and it you haven't substantiated. No, it didn't, dude. I still got the tab.
Open it and actually read it then.
I did.
Okay, read any article, any Wikipedia article, anything that says.
Wikipedia.
You know what?
You really?
Maybe I'm wrong.
Wikipedia is not my alma mater, bro.
Maybe I'm wrong. Go ahead and give me a source.
You are wrong.
Go ahead. Sure. Let's pretend I am. Give me a source that says the electromagnetic radiation is not.
I already did.
Just one.
I already did. I gave you four sources.
One.
I gave you four.
I just need the one. What's your best?
I gave you four.
What's your best?
Okay, let's scroll back up, dude. I'll just read it again.
No, you don't need to read it. Just give it to me.
Quantum Electrodynamics by Richard Feynman.
Perfect. You're going to post it, right?
Quantum lecture on quantum electrodynamics.
You don't have to read it. Just post it. Just post it. I don't believe
it
you.
is,
Just post
right there. Here's another one. Somebody else.
Just need the one.
No, you don't. You need more than the one, dude.
Okay.
You're a retard.
Okay. I mean, you're struggling with one, so let's
nobody's struggling, bro. Good try.
You sound like you're struggling. That's for sure.
Yeah. Here we go again. Back to the shtick. I wonder if these antics actually work on anybody.
So, do you have the transcript for Richard Feynman's lecture on quantum electrodynamics?
Well, I'll read it to you.
No, just send me the transcript if you have it.
Oh, hold on. It's probably available. Hold on.
Well, what are you reading then? You posted Richard Feynman's lecture on quantum electrodynamics. So what are you reading from?
No, hold on a second, dude. Hold on.
Were you lying?
No.
Sounds like you're lying.
Yeah, good try. Turn the topic into me again. You just tried 5 seconds ago. It didn't work then. It ain't gonna work now.
You're stalling.
Holy shit, bro. You're pushing my fucking patience, mate.
I don't care.
There they are, you pretender clown. At 40 minutes after the hour. From Richard Feynman. The first thing Newton believed light was corpuscular turned out that it had very strange properties from that point of view, and it was then explained that many of these strange properties was because, in fact, it was a wave, which was wrong. Turned out he was right. It was a particle. From Professor Shankar, Chair, Physics, Yale.
Just post the link.
Shut up.
Can't post the link.
You're getting your ass ripped up. Shut the fuck up while I rip your ass to pieces.
Post it.
Shut up.
Just post the clowny.
Shut up. I already did. I'm reading.
Oh, that's posted already.
Shut the fuck up.
Posted. No, that's fucking posted.
Shut the fuck up, clown.
Oh,
you're getting your ass reamed.
Oh, we're getting your ass.
Thank you. From Professor Shankar, Chair of Physics at Yale. Everything is really particles. All things, electrons, photons, protons, neutrons, they are all particles, so let there be no doubt about that. Back to Professor Shankar. So we have to play this game in two ways. It is particles, but its future is determined by a wave. But the wave is purely mathematical. You cannot put an instrument to measure the energy due to that wave. It's a construct we use to determine what will happen in an experiment. And finally, from the University of Tennessee, this is your ass. In one dimension, wave functions are often denoted by the symbol psi, x and t. They are functions of the coordinate x and the time t. But psi is not real, but a complex function. The Schrödinger equation does not have real but complex solutions. The wave function of a this is the really important part for you. The wave function of a particle at a particular time contains all the information that anybody at that time can have about the particle, but the wave function itself has no physical interpretation. Who thinks photons are riding on physical waves like Kelly Slater at the Billabong Tahiti Pro? You're done.
I already read all that to him, by the way.
Well, he's done. You're cooked.
Yeah, so you wanted a citation. Hold on. You wanted a citation. You can watch him say it. I posted the video of him saying it. You can watch him say it.
You're done.
Right. Are we going to continue to mute me the moment you get upset?
You're done.
No.
Yeah, because you're a dumbass.
You're still muting me the entire time.
You're a dumbass. You've been exposed.
He's a victim.
Well, no.
You were muted.
A victim.
You're afraid.
You were muted so that the citations could be reiterated without interruption.
No, it's simple. You got upset, you muted me, and then you went ahead and had a diatribe.
Poor baby.
Very simple.
You got your ass
Very simple. No, only cowards do that. You're a coward.
Done. You're done.
You're a coward.
You're done, diarrhea of the mouth. You're finished. Go back to your cake decorating forms, clown.
Gonna
You
mute
ain't
me
fucking
again.
over-talking me. It ain't gonna
Go
fucking
weave some
happen.
baskets.
We're not listening to your dumbass clown.
Your goal is
You're a
to get
dumbass
muted,
clown.
dude.
You're gonna
Shut the
be
fuck
water
up.
basket
Shut him
weavers.
up. He's a fucking
Weavers.
imbecile. You're a
Your goal
weaver.
is
moron.
Dude, you think
Wanker.
we don't know and everybody else knows.
Coward
Started
and
chanting.
moron.
Your goal is to
Clown.
get
You
muted.
think that electromagnetic
Transparent.
Fucking light's not electromagnetic, you abject moron.
Yeah,
Photons
I know.
are
I
neither
argued him. He said light's electromagnetic waves. We sat there and fucking argued, and he tried to. His incredulity was boundless.
Yeah, fucking electron. They're not either electric nor magnetic, you abject idiot.